As we wrap up the week, we're going to see how we can use the concept of an antiderivative to find something called the average value of a function. So it's a definite connection between the skill of doing an antiderivative and being able to find the average value. So I'm going to show you how that works today. But first we're going to start out with a visual so we can understand why it works. So on this drawing here, I would pose a question to you. What two shapes do you see? So the one obvious shape that jumps out right away is the shape of the rectangle. But I would also challenge you to look and see a more non-traditional shape, the shape here that follows under the curve and then comes down. So the difference between those two shapes, that one of them's got that, the missing area, the area of one cancels out the area of the other. So we kind of have like this area here. Oops. Do it so you can see that. All right, so this area here and that area sort of cancel each other out, in other words. Okay, so we've got, I don't know what you want to call that. We have that yellow shape. All right, so the question is, how do you find the area of each shape? Well, if you're in a rectangle, we want to go base times height. So our base down here is b minus a. And then the height of the rectangle is along this dotted line here. Okay, and that height is above the number c. We don't know what that number c is, and so the height, we can see over here, is f of c. So it's b minus a times f of c. That's base times height. The yellow shaded area is not a geometric shape, and so the only way to find the area of that is to do it by integral. And the integral goes from a to b, and it's following the curve f of x dx. Okay, so two shapes and two strategies to find their area. One is a strategy of geometry, because we have a perfect rectangle, and the other is the strategy of calculus, where we use an integral to find the perfect area. All right, what the average value theorem says is that the areas of those two shapes are equal if you place c in the right place. It's all about where you put the c, because if you put c in the wrong place, if you put c over here and you come up and you're like, oh, I'm going to make my rectangle this tall, then the rectangle and the yellow shaded area are not going to be the same size, not going to have equal value. You have to put c in the right place. All right, so the average value says if this is continuous, then at some point c, it is true that b minus a times f of c is equal to the integral from a to b of f of x dx. Okay, the rectangular area and it's done with geometry, is equal to the irregular area done with calculus. That at some point c, if you pick the right point, that those two things would be equal. Okay, now that's the theorem. Those two things are equal. Now we can do things to that theorem. Specifically, if I asked you to get rid of b minus a, in other words, how would you get f of c by itself? Okay, here's your f of c. How do you get it alone? And hopefully you're comfortable enough to say, oh, you divide by b minus a. That's how you get it alone. And so if I asked you to get f of c alone, then you would have a to b integral of f of x dx divided by the quantity b minus a. And that being able to get that alone is very helpful. This is why. Because when we get that f of c alone, that gives us what is called the average value. The average value is f of c by itself in that expression, where you have the integral part on the top and the base value on the bottom. Okay, integral on top, and that base is an interval. The interval, along the x-axis. So a lot of times we use those two words, integral and interval, to help us remember this formula. The average value is the integral over the interval. So, if I, like a snap definition, if I say to you, hey, tell me what the average value is, you spit back to me integral over interval, and I'll say, okay, write it down. And then you'll write down the integral from a to b of f of x dx, and then over the subtraction of the interval for b minus a. Now, we're going to evaluate this 3 different ways, because we have 3 ways to find an integral. We can do an integral if we know the perfect geometry. If we have our calculators, we can do the integral with Math 9. And then we also have the antiderivative as a way to do the integral. So the integral part is going to come from one of these ways, and we'll practice each of those. And then divided by the interval part, which is just simple subtraction. So here we go. Find the average value of the parabola 2 minus x squared on the interval 0 to 4. All right, so the definition of the average value is integral over interval. And that is equal to f of c. So the integral from 0 to 4 of parentheses 2 minus x squared dx over the interval 0 to 4, so 4 minus 0. That's the math, that's the setup. Now it's up to you to do the rest of the work. So you'll do an equal sign and then a bracket, and we're going to use antiderivatives. So the antiderivative of 2 is 2x minus the antiderivative of x squared is x cubed over 3 plus c from 0 to 4. And then that's over still the interval of 4 minus 0, or just 4. And then we'll do the math to work this out. So we're going to plug in the number 4 first, and then we'll plug in the number 0. So this will be in parentheses 2 times 4 minus 4 cubed over 3 plus c, and then minus the second set of parentheses 2 times 0 minus 0 cubed over 3 plus c. And the whole thing is over 4. So that simplifies to be 8 minus 64 thirds over 4, which simplifies overall to be negative 10 thirds. Okay, now connected to the visual representation. So let's see, what does this mean? What does it look like from a visual standpoint? Okay, I moved a few things so that we have a little bit more room to work. So I'm going to draw or sketch Okay, 2 minus x squared, that's a parabola. And we're going to go from 0 to 4. All right, so that means that the area all in that parabola, so that would be this area that's above and this area that is below, that amount of area, I'm not saying that that amount of area is negative 10/3. I'm just saying that that amount of area, whatever it is equal to a rectangle that would be drawn at negative 10/3. So down here on the y-axis, straight across. And that area, that red area is the exact same as the yellow area, as the total of the yellow area. In other words, what's happening is that the area in here and the area down here cancel each other out, and then we've got the area all together. The final question is, at what x value does the average value occur? So this is a little bit of algebra there. The question is, where is this intersection spot happening? Okay, well, that intersection spot is happening where negative 10/3 crosses the parabola line. So you got to do a little math on the side, but it's not terrible. So where negative 10/3 crosses the parabola line, 2 minus x squared, and then we'll solve that. So what I would do is I'd multiply everything by 3. That would give me this equation. Okay, I just multiplied all terms by 3. Then I would subtract 6 from both sides. So negative 16 equals negative. Divide by negative 3. So that'll give me positive 16/3 equals x squared, and then apply the plus or minus square root. So this is happening at the x value of positive or negative 16/3. The negative one would be on the other side of the parabola. We're only looking for the one on the right side of the parabola. So it is going to be positive 16/3. I'll get rid of the negative sign. Okay, that's where that's happening. Working our way backwards. Okay, so overall, what did we do? We defined the average value as the integral over the interval. We set it up, we wrote out the integral and the interval values, and then we used antiderivative to solve it. Then we drew a picture of the shaded area and the rectangular area, and then we solved where that rectangle intersected the parabola to find the solution. All right, so we're going to try this again. Find the average value of this absolute value graph from 0 to 3. Okay, so average value, definition, f of c equals integral over interval. So the integral is 0 to 3. 3 plus absolute value, x minus 2, dx over the interval 3 to 0. So this is the setup. Now we decide how we're going to do this. And we have 3 ways. We can do basic geometry. We can do Math 9 if we had a calculator. Depends on what the problem says. Or we can do an antiderivative. Okay, this one, an absolute value, is a great one to do with straight out geometry. So we're going to do plain old geometry on this one. All right, the absolute value moves 2 to the right and 3 up. And then the absolute value simply comes down like this. And we're going from 0 to 3. So my shaded region looks like this. It's not a perfect triangle. It's not a perfect trapezoid either. But it's two trapezoids back to back. Let me show you where the two trapezoids are. All right, we've got trapezoid number 1 and we have trapezoid number 2. So we're going to find the answer to this using geometry. So the first trapezoid, T1, the formula for the trapezoid, 1/2 times the base of 2 times the heights, which are 1 and 3. That's the first trapezoid. And the second trapezoid, 1/2 times a base of 1, and then its heights are 3 and 2. And the whole thing is over the value 3. So that turns out to be 4 plus 5/2 over 3, which is 13/6. Okay, so visually, what does that mean? That means I go to 13/6, which is a little bit over 2. It's okay, about right there. And I make a corresponding rectangle going straight through that. And the area of that rectangle with a base of 3 and a height of 13/6, that area is exactly equal to the original area. So that's the visual representation of that. So where does that happen? At what what C value does that happen? So that's going to happen where the 13/6 intersects with the absolute value. So 3 plus absolute value x minus 2. So we solve that. You remember how to solve absolute values? When you take away the absolute value sign, it becomes plus or minus. Remember that from algebra? Now we're going to multiply everything by 6. So that'll give me 13 equals 3 times multiplying that by 6. So that'd be 18 plus or minus 6 times x minus 2. Subtract 18 from both sides. So that'll be -5 equals plus or minus 6 over x minus 2. Divide by plus or minus 6. So that'll give me plus or minus 5 divided by 6 equals x minus 2, and then add 2 to both sides. So 2 plus or minus 5/6 equals x. And the x value that this will satisfy, there's 2 of them. It's because the rectangle intersected twice. So those 2 places are both places that solve this average value problem. So again, recap. We define the average value by writing down f of c as integral over interval. Then we write out the integral. Then we decide on a strategy to solve that integral. This one happened to be a geometric strategy. That works great for absolute values. We did the geometry, and we came up with the value, the average value of 13/6. That 13/6 becomes the height of the corresponding rectangle that has the same area. And we set that 13/6 equal to the original function to solve for the solutions for x. Okay, let's try another one. Find the average value of 5 plus the natural log of x on 1 to 5. So let's define that. The average value is integral over interval. Let's write the integral, this time 1 to 5, parentheses 5 plus ln x dx over 5 minus 1. All right, this one is one that is going to be a calculator active problem, so we can use a Math 9 on this to solve our integral. And so you'll grab your calculators, you'll do your Math 9 from 1 to 5 of 5 plus the natural log of x, which gives us an irrational number that we're going to have to round, 24.04718956. And all of that is over 4, 5 minus 1. So the solution is 6.0118. That is called the average value. So visually, what does this mean? Well, the graph of 5 plus the natural log of x looks like this. There's 1, 2, 3, 4, 5. And so the area trapped underneath that curve. And then if I go to 6.0118, and I do a rectangle that is that tall, this rectangle has the same area as the yellow. All right, and now we're going to solve. So 6.0118 set equal to where it crosses the function 5 plus the ln of x. So we're going to subtract 5 from both sides. That'll give me 1.0118 equals the ln of x. And then we want to get x by itself by applying e on both sides. And what that does is it cancels out the e and the ln to give me x by itself. And then my calculator would tell me what e to that value is. And I get 2.7505. And that's the x value where this is intersecting here. Okay, so you're going to do this on your own, finding the average value. Look for whether or not you have your calculator or not. If you do have your calculator, go ahead and use Math 9, but not before you write down the integral. Make sure you write that part down, the definition. Okay, and then you're welcome to use Math 9 to solve. If you are not able to use your calculator on that, then that forces you to practice either your antiderivatives or practice your geometry to find the value of those integrals so that you can find the average value. All right, so you're going to work on this. Sign up for a time on Friday if you're struggling with these antiderivatives, if you need a little bit of a refresher on some of it. Otherwise, I wish you the best weekend, and I'll look forward to seeing you again on Monday.